Hello people, welcome to my YouTube channel and my name is Aviral. In this video we're going to discuss about the second iteration of the component placement for STM32, and we'll also discuss about the differential pair routing, how to calculate the characteristic impedance of differential layer, how to place the differential layer symbol on schematic, how to import those changes, and a lot of things. But before that, there is a huge giveaway going on my YouTube channel. So what you guys need to do, just click on community tab, and from there you will be redirected to my first post that is here, and there is a link on the description. You can also click on that link and fill the form, and if you guys fill the form you will get 3 very popular gifts from me, and that the first one will be the high speed digital design book by H.W. Johnson. This is also known as the Black Magic of High Speed, and the another book will be the Circuit Design Companion by Tim William. This is very popular book, and another gift will be the thermal simulation tool for PCBs. So guys, hurry up and fill the form. But before going further, this video is sponsored by NextPCB.com. So NextPCB is one of the best manufacturer of PCB. So if you go to their website, there is a huge sale going on, like for all layers of PCB, whatever the layer you want to manufacture. And if you register right now with the link given in the description, you will get flat $5 discount on your account, and they'll also support the PCB prototype. Like if you are designing PCB for the first time, they will charge $0 from you, and they will ship your product within 24 hours. So obviously, like, lead time is very big concern for the designers, so they'll ship within 24 hours. This is very good thing. Please guys, grab this opportunity and register right now. Till here we have finished the component placement of STM32 controller. So here, as you can see, we have placed all the components. So now firstly we'll go for the differential pair net. So as you can see, so here I have placed D_P and D_N. So here P stands for the positive part of data, and DN is the negative part of data. So as you can see, so like if we named any of the net with _P and _N, Altium Designer already make itself as a differential pair, right? So you just need to just make them as a like _P and _N, and it will automatically consider it as a differential pair. So now what we're going to do, we're just going to assign a differential pair net class to these particular nets, so we can import those on PCBs. So firstly we'll right click on the PCB document and just click on merge all. Now we're going to place the differential pair net class. So what you should do, you should go to this menu, and here you have to right click here and select differential pair. So this particular symbol represents the differential pair. So firstly we'll place the differential pair here on the net, and then right click. Now we're going to edit the properties of this differential pair. So double click on it, just pin the property tab. So as you can see, its name is diff pair, right? So I'm just going to name it diff_90, right? Diff pair _90. So here I just it's a standard, so I'm just following that standard. So for USB communication, we needed the characteristic impedance, which is 90 ohm, right? So this is this characteristic impedance, like if you increase the impedance or decrease the impedance, the communication speed will be compromised. So you just need to maintain the impedance, right? So I'll tell you later how we can calculate the impedance of tracks, but before that we have to do that. So here, this is just a label. Now we're going to add the net class. So we'll go here, add, and differential pair net class. So I'm going to name it diff_90, enter. Okay, now I'll copy this thing, Control C, and paste it on the negative part. That's it. right? So here only we are using this differential pair. So in this controller this is the only differential pair and there is no component in the middle, so this is good. Okay, so here I saw a mistake. If you guys, yeah, so there is a mistake in the circuit. So here I forgot to add a pull-up resistor on D plus pin. So there should be a pull-up resistor, otherwise the computer will not recognize it as a USB. So what, I'll go to the component again. And just search for a 10K pull-up resistor. And I'll place it here. Like this. Save the project. And here it is also wrong. So what I'll do, I'll just make it correct. So this should be D_N. Now save. So like there we need to re-annotate the schematic. So we'll go to the tool, annotation, and annotate a schematic. I mean, I already told you guys how you can annotate the schematic, so I'm just doing it really quick. Now go back to PCB. So here I'm just going to import these properties, whatever the changes we have made. So go to the design, import changes, right? So these are all the changes. See, so our net was D_P and D_-. So the Altium Designer just made it D as a differential pair, right? Execute those changes and okay, close it. So there is one more register in our family, so we'll just firstly hide the designator. We'll edit the things later, and I'll place it like it should be very close to D plus, like this, so we can route it properly. I mean, officially we should avoid the avoid any kind of stubs on the differential layer, so that's why I'm just placing it very closer, so the stubs will be like not exceeds the length limit. So now we needed one more tool for to design this thing. So I'm just opening Chrome, and just search for STM32 toolkit. So we'll use that tool to calculate the track gap between differential pair and what should be the track width. So go to the STM32 toolkit website, and from there, so if you go down here, you will find the Windows version 7.08. so I'll click on that. So here you have to fill all the information, and after that they'll give you the download option. So just download this tool. So I have already downloaded and installed the software, so I'm just going to run the software first. So as I told you, we'll calculate the characteristic impedance and what should be the track width and track gap between the differential pair. So that we'll calculate here first. So just go to the conductor impedance calculator here, and here you can see you have three parameters: conductor width, conductor height, and frequency. Okay, so that is for this thing. So we'll select the coplanar waves. because differential travels through in single plane, right? So we'll change the properties here, the conductor width, the conductor height and gap. So we'll open the Chrome again, and here we'll search for mils to converter. So firstly we'll see about the conductor height, which is h, and in our case this would be the PCB thickness. So generally we'll manufacture the simplest PCB, which is 1.6 conductor height. So there we'll convert it to mil first. So here we should type 1.6, and it is around 63. So we'll put 63 here and solve. So here we can see the characteristic impedance is around 100 ohm. So now we'll adjust the width and gap. So let's go for 8 mil and the gap 10 mil and solve. So you can see now it is 92.9 ohms. So this is the closest and the safest clearance and gap that we're going to follow. So now what we'll do, we'll open the Altium Designer. So here you can see there is a tab PCB. We'll go to that tab, click on net and go to the differential pair editor, and we have created the net class, which is diff90. So we'll select that class, and here we'll click on the rule wizard. Now next, just name it the same, diff90. Next, so we'll leave it as default. Next, here we will fill the properties that we calculated. So the conductor width should be 8 mil and the conductor gap should be 10 mil. So this is the width. We can convert it to mils by pressing Q. Okay, so just cancel it first for now. So right now you can see the units are in mm. We'll press Q and it will be changed into mils. Now we'll again click on rule wizard. Next, we'll do the same thing, 90. Next, and here we'll fill 8 mil. Preferred width will be 8 mil and the maximum width will be 8 mil, and the gap is already filled, so we don't need to worry about the gap. Now we'll click on next and finish. So here we have created the rule for differential pair. So we already did the first iteration of component placement. So we'll just make few changes on the placement first. So we'll just split the screen again and go to the project and select the schematic file. Here we go. So now what we'll do here on the PCB file, just right click here and go to the view, connections and show all. So as you can see, so these connections are if you press Ctrl and click, you will highlight the connections. So press Ctrl and click on the pad. I think it's kind of twisted connections, right? So by crossing these much components, it will be very difficult. So how we can make them so clear? So if we rotate, okay, so if we select the component, okay, select all these things. We select the component, yeah, and rotate it. Okay, so this IC is locked now, so I'm just unlocking this, and if we rotate it like this, okay, it's kind of twisted. So now this is good, and if we place this connector there like this, then this is also good. Now I will select these components except IC, because we are kind of redoing the component placement because there was some issue before. So we'll place it here, and this one will be here, the IC will be here. So now you can see like all the connections are pretty direct and it will be on the top layer itself. Okay, these will be here. Now we'll select the oscillators. So one will be here. So this is coming here, this is coming that side, so we'll put it there. This will be in between these components like this, and similarly we'll place these LEDs here. So what I'll do, I'll just shift it a little bit there, so we'll get enough space to place LEDs on this place like this. Okay, and similarly now we'll place component one by one, so I mean it will be easier for you guys to follow. So we already placed the IC. Now we'll select these boot registers and place those closer like this. Another will be here. Okay, now we'll place these bypass capacitors. Select those one by one. So using the shift key you can select. I already told you on the placement tutorial. So I'll place those closer to the MCU pins like this. So I'll place them here, and another will be there, another will be this side, and one will be there. Okay, so we have placed these capacitors, we have placed these LEDs, it's there, right? We have to place this connector, but before connector we'll place the USB hub here, and the connector will be somewhere here, and this whole part will be together. We can place it there. We will align them later, so just place them right now. And these are the oscillator capacitors and the parallel resistor, so I'll place them here. Here we go. So we've connected all the components now. Edit, go to the view, connections, and again hide all. So we did the placement. Now we can go for the connections. So I already told you how to set up the differential line, so I'll just go to right click on the connection and select the interactive differential pair routing. There will be a green color plus sign on my arrow, so I'll just select the differential pair, and you can see both the wire will together. So now I'll do the differential connection first. Like this, it's done. Now I'll place the other crucial connections, which is the oscillator one. So it's like this. I'll connect this one also. So there is a sharp edge, so what I'll do, I'll just make it a little bit like this, acute angle. So we have connected all the crucial connections. Now save the project file. Now I'm going to connect all these connectors. So the first one is PB7. Select it. It's going like this. Now this. Another connection. I'll make them proper later. So firstly connect these wires one by one. So this wire is going nowhere, so now I'm going to make them proper. So what I'll do, I'll just select these connections, hold on, so just lock this connector, otherwise it will select again and again. So press the shift and click on each connection first, this. Now press the tab, control alt and G. So these all connections will be proper now. So this is the shortcut I always prefer. Right, now save the file. Now I'll connect these connections. So if I'll select this one, so this is the ground, this is PB12. So press control and right click, so it will kind of, okay, so you can see this is after the differential pair. So I mean, we all know that we can't cross the differential pair. There should be a proper ground under the differential line. So what is the solution then? Route it like this. From here we'll make the connection. Okay, so the solution is we should remove these thing from here to somewhere outside. Obviously the orientation will be proper, as I told you on previous videos. Okay, even we can place it here, so it will be like this. Now what we'll do, firstly we'll start with this connection, PA12. Press the control, click. So if we dim it a little bit, it's not going anywhere. PA12. Now we'll select the another connection, press the control and click. Okay, press the control and click here, yeah. Okay, so this is going this side. So what we'll do, we'll just route like this, place the via from here. So I'm using very small vias here because these are the signals and there's a not much amount of current will flow through the connection. So now I'll change the layer to bottom layer. So I have to click here. If it's not changing, you can change the layer like manually. So this will go here like this. Now I'll press the control and click here. Okay, I need to do the same thing for this one also. So the solution is I'll just make it longer like this, so I can place like multiple vias. So I'll just copy the via, Control C, click at the center, Control V, like this. And make the other connection, change the layer by pressing L, so it will be like this. Okay, now click Control and this one. So now Control V to place via. L for layer change. Now we'll press Control here. So this is also kind of thing. So what I'll do, I'll just make multiple layer change. So firstly it will be top layer, then I'll press Control V, place the via, then it will be the bottom layer, now we'll Control V for via and just adjust this thing a little bit. Now we'll make this connection like this. Now I'll click on another tab, so it will be like this. These will be also like this, and this can be here. So firstly it will be the top layer. I just shift it a little bit, sorry, Control Z, because I shifted the IC. So select the IC and lock this component so it can't move without our permission. Now I'll Control V here. L for layer change. Now I'll just do this here. Control V for via. Delete this and route it properly. Now this is good. So another connection is here, PB13 and PB12. So what we'll do, we'll route those connections later. So now we can go for these connection routing. So the first will be PB8, which is going this side. So again we'll directly use the bottom layer, press tab, sorry, the backspace. The connection is not going the same side wherever we want. Now I'll select this one, here. Now I'll select this one, should be that side. Now I'll select this thing, so I can connect it directly. So change the layer to top layer and connect it directly. We can do the same thing for this one, for this also. We'll make them proper later. Firstly we'll just make the connection. Connect this also. Okay. So backspace, right click. So this is okay, this was 3v3. So we have made these connections also. Now what we'll do, you know that we'll select, press the shift and select these of one of the each connection. Press tab, alt, control and G. So it will make proper all these connections, as you can see. Now we'll connect these with bottom layer. So control V, place the via. Okay, so I moved this component, control Z, select the wire, make it there, control V. For this one also control V and place the via. Now we'll connect this first. So I'll just make it like this, straight. Again press control, select the wire, now I'll select the another wire, control and click. Okay, so this one is going this side. Okay, so till now we have made all these connections. Now we'll connect these two also, which we left on the other side, this one. So this will go from here only. So we have to make some space here, so we can go for this connection. Later we will arrange those. Control V, place the via. Okay, so via is not proper, so we'll place it here like this, and just make the connection with this one. So we'll place via, Control V here, L for layer change, connect it here. Now we have to do this last connection, which is this. So firstly place the via here, Control V, then route the bottom layer connection like this. Now we have to make some more space, so we'll just shift these connection a little bit far from there. Later we'll arrange those, so don't worry about those. We'll place the via here, this one there, delete. Now we'll place a via here, Control V like this, route a top layer connection from there, it can connect here. So we have made this connection also. Now what we'll do, you know that we'll select, press the shift and select each connections one by one. Press the tab, now Control Alt G. So now these connections are proper. Press the Control and click anywhere. So we have made these much connections. Now we'll connect the others. So for other layout, what we'll do, we'll just going to enable the connection. So go to the view, connections, and show all. So we'll just target one by one, and firstly just go to the bottom layer and route these connections first. So how I just change it to single layer mode using Shift plus S. So if you Shift S, you can switch between these modes, right? So this will be easier, like you can watch only layer. If I'll select the top layer, I'll see whatever the things on the top layer only, right? So go to the bottom layer using Shift S and select the wire, connect it. So here I'm making this wire a little bit thicker, as I told you guys. So how you guys can make this wire thicker, go to the design, rule, and go to the routing width here, and from here just make it max, which is 50 mm. If in your case, if it is 10 mil, then just make it 50 mil and click on apply. And you have to do one more thing, go to the rule and go for clearance and just make it 5 mil. Now just go to the routing tab, press tab, and here from here you can change the width. Okay, so I mean on a lot of videos I mentioned all these things, so this won't be an issue. So let's connect this first, because this is a 3-volt wire, and this will be like this. Now we'll connect the another 3 volts, which is here. These are the NRST. So for signal layer I always use 10 mil, as you can see here. Okay, so these are the connection we have routed. Now what we're going to do, we're just going to highlight the ground first. Okay, so go to the PCB, select nets, all nets, and just select the ground from here, this one, right click, change net color, and I always select this. Okay, now select ground. So you can see all the grounds are highlighted. So if we press the shift S again, now go to the mechanical one, so we can see all the open connections, and these blue one are the ground. So we'll leave the ground first and connect all other connections. So firstly we'll connect all the smaller ones first. So this will be like direct connection. So here we have to make some space, so we can connect these wires. So select the tab and route these like this. Okay, now we'll shift it a little bit there, so we can place via and make the connection. Now Control V and place the via here. Connect it. Okay, now we'll look for the another connection. Using shift S we can switch between the layers. So this is the NRST which is going here. So what we'll do, we'll just make the connection like this, place the via and connect it to NRST like this. If you want, you can place it closer. Sorry, Control Z. If you move something, just go for Control Z, and Alt, Control and G to make it proper. Now again we'll press Shift S to see other smaller connections that we can go for. Yeah, there is the one. So we'll connect this also. So to connect this, we needed this here. Place the via, go to the bottom layer and connect this to this. Again Shift S, mechanical one. So these are the connections that we can make. So these are the 3v3 lines. We'll connect those. Let's highlight the nets first, so we can connect them together. Okay, so this will be 10 mil. Control V, place the via and connect it. And now here only, so connect these two here, place the via, tab, make it 10 mil and connect like this. For these ones, so you need to use via here. Control V, via and connect it. Sorry, change the layer from here, select the bottom layer, press tab, 10 mil and connect it like this. Now here Control V and connect it like this. So these are also connected together, so I'm making these connection also. Okay, so this is the top layer. Select the top layer, connect it, and later if there will be like any crossing from here, we'll modify the connection later, but for now we'll just going to make these connections. Press L to change the layer. So this will be the bottom layer. So this is the power line, so we can connect it like this, and for this one also we'll connect it like this. Similarly, we'll connect this line to here. Now we have few 3v3 here, so we'll connect these first, then we'll use VRs and layer change to make other connections. So these are just for powering the LEDs, so that's why I'm not like thickening the tracks. I'm just using the 10 mm thickness. Control S to save the design file. So we have made these connections. To connect this part, we'll use the thicker trace because there will be like lot of connections. So tab, make it 20 mm. And change the layer to bottom layer, and I'll connect this to here. So all the 3v3s are connected now. Now we'll press Shift S, Control, click anywhere, and go to the mechanical layer so we can see all the other connections. So there is one more connection which is going here, so I'll connect that first because that is the smaller connection. Okay, so this is the P. Okay, so I'll connect it like this so we can avoid the longer stub. So for that, what we'll do, I'll just place it on the pad, Control V, like this, and this connection will be deleted, and we'll connect to the bottom like this. Okay, now there's one more 5-volt line, so that will be connected from here only. Tab, make it 15 mm like this. Okay, now Shift S, mechanical one, and see other smaller connections like these ones, so we'll connect those first. So here this is going to boot one, Control, click here, just use the bottom layer, tab, 10 mm like this, make it connection, Shift S, mechanical one, Control, click anywhere, and you will see other smaller connections like these ones. So we'll connect these first. So this one is going here, so we'll go to the bottom layer first, Control V, place the via top layer and connect the top layer, right? Similarly, we'll connect here, go to the bottom layer, place the via, right click, top layer, connect like this. Okay, now Shift S, mechanical one, and see for the another connections. So these are also we should connect. So I'll just connect it through bottom layer. This one is connected here. Now there should be the Control V here, top layer, connect it through the shortest connection. Similarly we'll do here. Control V, connect it like this. Shift S, mechanical one. We have few more connections left. So the one is going here, and RST. Okay, this one. So how we'll connect this? Let me think first. So we'll shift this little bit there. We'll trace a wire from here to here. Okay, then we'll change it to bottom layer again. Okay, got it. So firstly we'll hold on. So firstly what we'll do, we'll just, okay, we have here, so we'll just L to top layer, tab, make it 8 mil, some more thinner, tab 8 mil. Okay, so I can't make it 8 mil, so what I'll do, tab, design, rules, go to the width and just make this to minimum to 8 mil, apply, okay. Now it is 8 mil. Now I'll press via here, shift it a little bit there. Now we'll change the layer to bottom like this. Right click, Control V, place the via and connect the reset. Control Z, like this. Okay, now we'll control, click anywhere, shift S, mechanical one. So there's few more connection left, so we have to connect those also somehow. So the first one is this one. Press Control, click here. Yeah, right, this one. So it's going like this. So how will make it possible? We have to shift these things. Okay. So we can route from here to this. Got it. So what we'll do, we'll route from the here like this. Now Control V here, go to the bottom layer and connect it. Right, now press Shift S, mechanical one, click anywhere. So we have 3 more connections left. Now what we'll do, we'll just click here and see it's going this side, so we'll go like this. Now change layer. Okay, so what we'll do, we'll go like this here. We'll place via, Control V, change the layer to bottom, L, like this, and make it connect to this one. Now we'll connect this thing also, so it's going this side. So how will make it connect? So this will be here, from here it will be bottom to here. Okay, fine. So what we'll do, we'll just drag this connection here. Hold on, select the top layer first. Now drag the connection here, Control V, click here, change the layer to bottom. Now follow this route like this and connect here. Click anywhere, press Shift S, mechanical one. Now there's one connection left that we need to finish. So for that we'll follow so the connection is here. This is bottom layer. Okay, so firstly what we'll do, we'll connect this to bottom layer. Now we'll place the via, change it to top layer, now we'll follow this particular path to make this connection like this. We'll select tab, Control Alt and G, so we'll make it proper. Now Control S. So till here, if we'll Shift S, mechanical, except ground, we have made all the connections, right? Shift S, and now we'll go for the ground layout. So for ground, you have two options. Either we'll place the ground polygon pore, or we'll make each connection individual. So what I always do, I just place the ground polygon pore because that is the easiest method that we can show. But before that, what we'll do, we'll just place the keep out layer. So what is keep out layer? Keep out layer is the minimum clearance from the board outline that we required. So for that, what we'll do, we'll go to the design, board shape, create primitive for board shape, left click, and here we'll select 5 mm, include cutouts. From here we'll select the keep out layer and OK. So like you can see here, this track is almost touching the board outline. So for that, what we'll do, we'll just shift this track a little bit inward and this error will be gone, right? So now what we'll do, we'll place the polygon pore. So go to the place, polygon pore. So right now the layer is selected mechanical mode, so we'll place tab, select the top layer, the net will be ground and it will be poured over all same net object and remove dead copper. Now we'll start from here, click on each corner, here, and right click again. So it poured. So why it is blue? Because we have changed the color. So if we'll unselect this ground, it will be like this. Okay. Now we'll do the same for bottom layer. Place polygon pore. Click on each corner, tab, change the layer to bottom layer and right click, right? So we have did that. So as you can see, there is still few connection which is not connected to ground. So for that, what we'll do, we'll just use the stitching net or stitching vias. So for that, what we'll do, go to the tool, via stitching, add stitching to net. From here we'll select 50 mm, from hole size we'll select 10 mm, diameter we'll select 20 mm. These will be tinted. we'll use the ground net for via, and these all vias will be locked, and press OK. See, so we have stitched the connection. Still we have few connection open, so for that what we'll do, we'll just route a wire externally to this one. Now what we'll do, we'll press Shift S, mechanical one, and you can see all the connections are done. So it's time for designator placement, but before that I just want to show you the 3D model that we have created. So here we have this mistake, just make it proper. So for re-pouring all the board, what we will press, we press T, G, A, and it's re-poured, right, as you can see here. If we go for the 3D view, you can see the 3D view. So here you can see the vias are not stitched properly. So what we'll do, and it is these cross connections, so I don't like these kind of connections on via, because it's like visible on your PCB. So to remove those, what we'll do, we'll go to the design rules, go to the polygon pore. Where is that? Routing topology, planes, polygon connects, click on the polygon connects, and here we should select the direct connect, apply, and OK. Now we'll press again T, G, A. Here we go. Right, so all the connections are now direct now. So what we'll do, we'll just go for the designator. So we'll just unhide one designator, click on the designator, press Shift plus F, and there will be a green cursor. We'll click on the designator, select the same, OK, and click on this one time, and all the designators will appear, right. Now what we'll do, we'll go to the layer set, and just always select the all layer, go to the top layer and press Shift S, and only these designator will be visible. So we'll place these properly, select the designator, place them properly, just remove from over the holes, otherwise these will be like chopped by the manufacturer. So U1 will be here, the switch should be here, ground, J3. Now we'll go for the bottom layer. So it's like all the designators are inverted. So what we'll do, we'll press Ctrl F, and it will just flip the board. So R7, this is the component that we have added later. Just change it to our size that we are using, 30 mm cross 6 mm. And now we'll arrange these also. C8 will be like this, R7 like this, this will be like this. So always follow a pattern, like if the numbers are on the top, then for each component it should be on the top, right? Don't just mix up the thing, otherwise it just look very bad and it's not professional designing them. So always follow a pattern. Oh yeah, I always miss it. Okay. these are fine. If you want, you can make it like others. Here we go. So we made all these things here. Now we'll again press Ctrl F and go to the layer set, and all layer, press Shift S, and one more time. Here we go. Now we're going to name this board. We'll place the board name, and we'll just name this thing also. So what we'll do, we'll just select the top layer and string, tab, change the value to 30 mil, tab, and make it 6 mil, this thing. So what we'll do here, so this is boot 0, another one is boot 1, so I'll just type here boot 0 and place this side, and this string will be placed here, that will be boot 1. Oh yeah, that is 0, and select the string, that will be boot 1, place it here like this. Okay, now we're going to place the name of each pin. So which pin is what, so we'll select this, copy, Ctrl C, place here, Ctrl V, and place like this, Ctrl V here, Ctrl V here. So this one is ground, this is also ground. So we can do one more thing. From here we'll just off all these things and just select text. So I mean, we can't able to select other things. Okay, and this will be plus 3v3. Similarly, Control V, let's copy these, all these, we'll change them later. Control C, and now Control V, place them there. Again Control V, place there, Control V, place like this. Here we go. Similarly place here. So we are just naming all the pins. So obviously this is the controller and we should know which pin is for what purpose. Control V. Here we go. So till here we have changed. So this is ground 3v3. This is PB7, sorry, PB11. This is PB10. This is PB1. This is PB0. PA7, PA6, PA5, PA4, this is PA3, this is PA2, PA1, PA0. This is our reset, NRST. This is PC13. This will be PB9, PB8, and the last is ground. We'll do the same thing on this side. This is ground, this is plus 3v3, this is PB7, this one is PB6, again this one is PB5, 4, 3, PA15, PA12, PA11, this will be PA10, sorry, PA9, PA8, PB15, PB14, PB13, PB12 plus 3v3, ground. Here we go. Now we will go for the 3D view, but before that there is one more connector here. So we can't place naming on this place, so we'll make a section here. So what we'll do, we'll just copy one name here from here, Control C, click, Control V, place like this, Control V, Control V, and one more like this, and we'll put it in a box. So the first pin is ground, second pin is SWCLK, third pin is SWDIO, and the last pin is plus 3v3. What we'll do, we'll just make a box for this. Like this. Okay, now we'll go for the 3D view. So as you can see, okay, so right now these all the VRs are exposed. So what we'll do, we'll select one VR, just click on here to enable all, select one VR, shift F, click, same, okay, and now go for the manual, tint top layer, tint bottom layer. Now click, now go for 3D view. So as you can see, all the VRs are tinted now and all the namings are proper, as you can see, for each pin. If you see the bottom layer, see all the components are properly arranged. Now press Ctrl F. I will show you how you can change the color of the PCB, because generally blue pin is blue color. So we'll go to the layer set, click here on the color, and the color window will appear. Here what you can do, go to the view option, and here you can see the top is solder mask and bottom solder mask. Click here and make it blue. Click here, blue. Now we'll hold on. Okay. Oh yeah, why it's setting there. Okay, now close it. So as you can see, our PCB is blue color now. Okay, so from there you can change it to any color. So in the next video we'll going to discuss about the output files. Thank you.